I'm going to teach you how to solve a pool problem using the law of conservation of momentum. So the law of conservation of momentum basically tells us that whatever momentum you have before objects crash into each other should be equal to the amount of momentum you have after the crash. So I'm using pool as an example because it's a game where you're hitting the cue ball into other balls. So there's a lot of collisions that are happening, and you can see evidence that momentum is being conserved in this game. So the example I have here is, imagine you take your pool stick and you hit this cue ball. I'm going to label it M1 to show that it's object 1 and it has some mass, which I can give you later. And I'm going to say that we're going to hit it in this problem at a 30-degree angle from the horizontal. So we come in and we use our pool stick to hit this ball, and we're going to say that this other ball, which I showed in black, this ball is at rest. So it has, let me label this as M2. So we're going to call this object 2, and its velocity is 0 meters per second. And we're going to say for this example that object 1, which is the cue ball, has a velocity of 10 meters per second. So we hit it at a 30-degree angle. After the collision, I have a diagram showing what they do after. So they hit each other, and we're going to say that this white ball is going to move this way at some unknown velocity at a 40-degree angle from the horizontal. And the black ball, which we shot at, is going to move in this direction at a 50-degree angle from the horizontal. And these angles are sort of arbitrary. It just kind of depends on how you hit this ball with your initial hit. Is it dead on? Is it off at a side? So we're going to say this happens. And so what I'm trying to show here is, if you know their masses and their initial velocities at the beginning, which we do, and you know their masses after the collision stay the same, and you know the angles at which they part, you can actually use the law of conservation of momentum to solve for both of these unknown velocities.